Solving logs with exponentiation. When we're solving logs by exponentiation, that's like the verb to make it an exponent. So we're making the ln 3x and the 5, we're making them the exponents of the same base. And that base is chosen wisely. For ln, that's log base e. So we're going to exponentiate with an e. For log base 4, we're going to want to use a 4. That way the 4 and the log 4 cancel and we just get 2x plus 1 on that side. So we'll start the first problem, ln of 3x plus 2. Remember, we need to ask ourselves, is this 2 inside the log? And it's not in parentheses, so the answer to that is no, it's not. So I need to move it to the other side first and add 2. And I get the ln of 3x equals 7. To exponentiate, I'm going to make the ln of 3x and the 7 the exponent. So it's e to the ln 3x equals e to the 7th. And e to the ln of 3x is equal to 3x. And that is equal to e to the 7th power. And then divide by 3. So x equals e to the 7th divided by 3. And then if you wanted to evaluate that in your calculator, you can get a decimal approximation. X is approximately, let's see, 7e divided by 3 is 365.54. Our next equation, log base 4 of 2x plus 1 is less than 3. The benefit for using exponentiation with an inequality is it preserves the side that the x is on. A lot of times when we rewrite it as an exponent, we move the x to the other side, and when we do that, it messes up the inequality. So when we exponentiate, it's kind of nice for our inequalities to exponentiate. So we're going to use a base of 4. Now that 1 is inside the log, so I don't have to move it. 4 to the log 4 of 2x plus 1 is less than 4 cubed. So 4 to the log 4 of 2x plus 1 is just 2x plus 1 less than 64, 4 cubed. And now I can just solve that. Minus 1, 2x is less than 63, divide by 2, x is less than 63 halves, or I can make it a decimal, 31.5. And we have a domain restriction here because it's less than and it's a log. That cannot be less than 0. 2x plus 1 must be greater than 0. 2x plus 1 has to be greater than 0. Subtract your 1. 2x has to be greater than negative 1. And x has to be greater than negative 1/2. So that's the situation where we have to put another restriction on our domain. We have 31.5. It's less than that, and it keeps going until it gets to negative 1/2. So our answer is negative 1/2 less than x less than 31.5. Okay, and our last example is 13 times the log of 5x equals 26. So that 13 we have to divide by it first. And we get the log of 5x equals 2. Remember, this is log base 10, so we're going to exponentiate with 10. So 10, that's an ugly 10. Make that better. 10 to the log 5x, 10 squared. That becomes 5x equals 100 divided by 5. And x equals 20. Don't forget to just do a quick check to make sure that the answer you get works. When I plug in 20, it makes the log positive, so it works.